All right, let's dive right in. Today, we are looking at a really fascinating paper that tackles one of the biggest, most annoying problems for AI agents: why they're so bad at remembering things for long, complicated jobs. You've probably seen this, right? You give a super smart AI a task with a bunch of steps, and somewhere in the middle, it's like it just forgets what it was doing. It gets sidetracked, it gets confused by its own work. Well, it's a real thing, and there is a really specific reason it happens.
The whole issue really comes down to how these AIs handle their short-term memory, what the developers call context.
Okay, so think of the AI's memory like a desk. As it starts working, it just keeps piling stuff on. You've got tool manuals, the chat history, data it pulled from a website, error messages, and pretty soon, that desk is so messy, so cluttered, it can't find that one critical note it needs to figure out what to do next. And yep, there's a name for this: context explosion. And it's not just about the AI running out of memory space. It's that the quality of its thinking gets worse and worse because the important signals are just buried under this mountain of noise. Solving this, well, that's the key to unlocking what AI agents can really do.
So what do we do? Just give the AI a bigger desk? Well, this new paper we're looking at has a radically different and, frankly, way smarter idea.
The paper is called GenericAgent, and it's coming out of the Advantage AI Agent Lab, which is a joint project between Fudan University and Shenzhen Acquaintelling Technology. And what they've done is basically rethink this whole problem from the ground up. This, right here, is the big aha moment. For a long time, the thinking was all about bigger context windows, literally just building a bigger desk. But the new way, the GenericAgent way, is all about creating a denser context. It's not about how much you can remember, it's about how well you remember just the right things.
This quote from the paper's abstract just says it all. It's about maximizing the density of decision-relevant information. In other words, it's about keeping your desk clean and organized, with only the tools and notes you need for the exact step you're on right now.
So how does GenericAgent actually pull this off? How does it keep its context so clean and dense? Well, it uses 4 really clever mechanisms that all work together.
So here's a look at the overall architecture. I know it might look a little complicated, with all these loops for runtime and self-evolution, but it's all built on a few simple but really powerful ideas. Let's start with the tools it uses. First, it has a tiny, minimal set of tools. So instead of having a special tool for every single possible little thing it might do, it has just a handful of basic atomic tools. Think of them like Lego bricks, right? The agent just learns how to snap these simple tools together to do really complex jobs, and that means the instruction manual it has to keep in its head is super short. Second is its hierarchical memory. This is genius. It's like having a perfectly organized filing cabinet. The agent keeps just one tiny index card on its desk with a list of the file names. Then, when it needs some specific info, it reaches into the cabinet, pulls out that one exact file, uses it, and then puts it right back. The main desk stays incredibly tidy.
Now this third one, this is where things get really, really cool: self-evolution. After the agent actually succeeds at a task, it stops and thinks about what it did. And then it writes itself a little cheat sheet, a standard operating procedure, or SOP. If it's a task it's going to do a lot, it can even write a Python script to completely automate it. It literally teaches itself how to be better.
And finally, we have context compression. Basically, the agent is constantly cleaning its own desk. It summarizes what it's already done, it trims away all the junk, and it makes sure that its limited attention is always focused on the most critical stuff for the decision it has to make right now.
So that's the theory. But does it actually work? Let's just say the results they published are, well, they're kind of stunning. Let's see what this self-evolution looks like in practice.
The paper uses this fantastic phrase to describe what happens. The agent goes from high entropy, trial and error exploration, which basically means it's just fumbling around trying stuff randomly, to a deterministic, low-cost execution regime. In other words, it becomes a stone-cold expert that knows exactly what to do and does it super efficiently. And here is the punchline. Get this. After it learns how to do a task, the agent can do it again using almost 90% fewer tokens. And since tokens are basically the currency of AI, that is a massive drop in cost. And the amount of computation needed, it's huge.
This table just shows that journey perfectly. Look at round 1, the very first time it tries this GitHub research task. It takes 7.5 minutes and over 200,000 tokens. Ouch. But then look down at round 9. By this point, it's refined its process, it's written its own code to help, and boom, 1 minute 38 seconds, and only 23,000 tokens.
I mean, the proof is right there in the numbers. It works.
Okay, so the numbers are really impressive, but what does this actually mean for the real world? What can we do with this kind of super efficient agent?
Well, here's that GitHub task in action. The agent can, all by itself, go into a software project, dig through all the pull requests, figure out the related issues, and put together a perfectly structured report. For a human developer, that's a super tedious job that this agent can now just knock out with no problem.
Or get a load of this, a complete DevOps workflow. The agent is setting up a remote server, deploying a service, and it hits an error, and it just fixes it. It even handles a user jumping in midstream to change the requirements. This kind of complex, autonomous problem solving is a really, really big leap forward.
So at the end of the day, what this all means is that we are getting so much closer to having AI agents that are reliable enough and affordable enough for some seriously complex, real-world automation. And this isn't just for coding. Think about academic research, financial analysis, any field that needs to process a ton of information in many steps.
And that kind of leaves us with one last big thought. GenericAgent doesn't just learn a task. It learns how to learn more efficiently. So if an AI can teach itself to be more efficient, what's the next skill it's going to decide to learn completely on its own? It's a pretty powerful question to think about. Thanks for watching.